Hello, 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 everyone. Welcome to the Krhom Shop Live repair stream where we repair stuff and hopefully save it from the bin. So I think it's gonna starting pretty quiet today. It's all right. We have something to look into today because after last week's stream, I kept looking into the ESC we were looking at, and I found a few more things, but I stopped very quickly because I wanted to bring it to this stream. Hey. Hi Neo, hi Sun, hi Clyde, welcome to the stream. So yeah, that's something we're gonna start looking into first.
Hello.
Hello. Hello, Guillaume. So first thing I wanted to say, starting next week, this stream is going to start 1 hour earlier, and it's going to last 3 hours. The reason I'm doing that is because I'm going to be doing the last French stream on Thursday. I just don't have the time at the moment to work on other projects because of the live stream. So I'm cutting it down to one live stream. It's going to be the Tuesday one, but it is going to be 3 hours, and it is going to be in English. So sorry for everyone who really don't really understand English and only came to the French streams. I have to pick somewhere, and I know more people, more French people who can speak English or understand English than English people who do French. So I'm picking this one. So next week, it's going to start 1 hour earlier than today, and it's going to last 3 hours. And on Thursday, we're doing the farewell French stream. It's going to be the last one of the French streams. All right, so the thing I was talking about, this ESC. No, Clyde, we're not doing Chinese stream. I know how to say only a few things in Chinese, and those don't apply to electronics, unfortunately. I would probably get like a lot of people coming to Chinese stream otherwise, so it's a good idea. I'm going to work on that. So this ESC, I'll give you a quick summary of what we did last time and what I discovered after the stream. So let's look at it. So when we started looking into it, we found that this channel had 2 dead FETs that were shorted and 2 dead FETs that weren't opening up when I injected voltage on the gate. So I started by swapping them. They were swapped with slightly different FETs from the SPDB ESC. And those are this one, and these 2. And that still didn't work very well. I was still having a lot of, like, the motor was barely spinning. So then I kept investigating and found out that right here at the bottom, there were some tiny resistors that weren't reading the right value. So 2 of them. And I replaced them. And then the motor started spinning way better. As soon as I ramped up the RPM, one of the FETs would overheat and it would trigger my PSU protections. So we swapped this chip, which is the FET driver. Well, it didn't change anything. And we kind of decided, like, yeah, probably wasn't anything else I could figure out, because I can't really swap the MCU. So I said, maybe I'll swap the MCU and flash it to AM32, because it's BL32 at the moment. So if I swap an MCU, it's not something I can flash. But then I realized, like, I changed 2 gate resistors here for the 2 FETs that are here, but I never checked the gate resistors for the other 2 FETs I swapped. And let me show you under the microscope, actually. It's going to be interesting. Let me grab some tweezers and let me zoom in so we can see. So those, why is it rotated? Did my camera rotate a bit? I think it did. Yeah, should be better now. Or at least it matches what I'm seeing. Okay, so we swapped those two resistors here, those two, which were gate resistors for those two FETs. And I thought, well, I looked at the data sheet, and I thought these three pins are three gate connections to the MOSFET, to the three MOSFET. But there has to be three more for the other three MOSFETs. And so I looked at the data sheet, and the pins are actually this one on top, this one here, and this one here. So I checked, and let me actually show you. I'm going to go to resistor mode. So so you can recall, this is supposed to read 22 ohms. Let's wait a bit. Yeah, 22 ohms. And those three now have been repaired, and they read 22 ohms. This one, if you can see the trace, it goes here, and actually no, this one doesn't. Yeah, this one I think might go to this one indeed. Let's see if it's 22 ohms. No, that's not the one. It might be going to a via that goes to, maybe, I can't remember. I ended up finding it, which resistor it was, but it was fine. I don't remember where it is, but the other one, this one is this resistor, and if we look at it, reads, yeah, it reads almost open line, half a meg, so 500K. So that one needs changing. And this one, as you can see, or you might be able to see, kind of, goes to a via here. And I ended up finding that the via comes out here and goes to this resistor. And this also has a bad reading. Yeah, so 19, yeah, just 19. Oh no, so that's the good one, sorry, 22. So I need to find out, the other one will probably be this. Oh, I found it last time. I forgot where it was. Where's the one that corresponds to this pin? So this one needs changing. This one all the way up here is good. And the last one, I think it might be one of those. But what we're going to do is go to beep mode, and we'll find it again. Because if I've lost it, we need to find it. So I'm going to just put my probe here, and we're going to look for. That's this one. Okay, it is this one. And was it, or maybe I need to go get the data sheet again, because it might not be this pin, it might be one of the other ones. So let's have a look. Let's go ensure we have it right. That's a good way to check. Clyde asked if I cleaned the motor for last weekend. Yes, I did. We flew at a bundle with a bunch of magnetic dust and debris that went into the motor magnets, and it was horrible. So let me, I'll just need to find what the, is that the right data sheet? No, that's not the right data sheet. I need to go and find conversation about that's the one. And we can see the pins that corresponds to, I can show you actually. So it's good to know how to read a data sheet quickly to check the pins. And if you look into this page, it says high side, so LO123 are the low side gate drivers, and HO123 are the high side. And you can see LO123 are here. That's the one at the bottom of the three resistors I fixed. And the other one are indeed HO2 is the middle one, HO3 is the bottom one, and H1 is the top one. So I think I am correct then. This is the gate driver. This is the chip. The reason I was kind of wondering is because it looks like it goes to this, I think it goes to a VR and goes to the gate on the other side. So this should read 22 ohms, and if I go back to ohms mode, it does not indeed read 22 ohms. Yeah, 18K, 11K. Yeah, it's just a bad reading. So we need to change this guy and this guy for 22K resistors. And it's going to be fun like last time. It's super tiny, so it's going to be interesting. You bring back some of the bando to your rubber mat. Yeah, there's a bunch. I expect you had to clean and then clean the bench, clean the motors, then clean the bench. I also bought an industrial quantity of blue tack to clean motors next time. So, hey SerFPV, hey Danza. All right, so let's. I guess I can start by taking them off. Should be. I'll go 450. And I'll keep airflow like 60%. I don't want to blow stuff away. I'll grab my favorite tweezers for this job and orient the board the right way. So there's this guy and this guy. Okay, I'll clean my tweezers quickly. Might as well, so it doesn't stick much. Yep. All right, so let's remove them. Try not to shake too much. My fingers are a bit cold, but hopefully with the hot air I can warm up my fingers. Okay, one's down. And 1, 2 down. Not, the pad is perfectly clean here. I'll put some leaded onto them. Might actually try to pick up the. I'll go a tiny bit of wick and see if I can pick up the excess. The unleaded might help. It might help getting only leaded on the board, and it's gonna help with putting stuff back. So I'll do that. There we go. It's so small. There we go. See if I can use the other side of the braid that's not coming apart that much, as much. Let's try to use the flux. You can see the powdered flux on the braid. There we go, nice and clean. Now let's put down a bunch of flux, put down some leaded, and we'll be good to put, and then I'll go grab the replacement resistors from the bags. Some solder, as the Americans say. Hopefully you're all doing all right tonight. I know it's Tuesday is not the most exciting day, but hopefully everything's good on your end. Could I get this not to beat up? I'll try to. Oh, I'm getting some triggering from Spaneris on Discord. If you can mute yourself, please, if you're not talking. Or we're gonna have to mute you, which wouldn't be nice. Come on. Oh, there we go. Thank you. Spaneris, you're still triggering. Just letting you know, we're gonna have to mute you if you're not muted yourself. Grimka, could you mute him, please, if you're still around? Thank you.
Yep, I've done it.
All right, so we got that. I'm gonna clean it up and add some more flux, and then we'll go get the resistors we're looking to add. Get some nice shiny leaded solder pads. There we go. I managed to scrape the copper a bit around them, but it's not the end of the world. Right. Now I'll bring you with me in my search for the right resistor, because I have those silly bags of all the resistors and capacitors. And I need to find 0201 resistors, 0201 resistors. Those are the high values. I have two of them. I have one for the high and one for the low values. 201 resistor, now must be it. This one. Pack the other ones away. Hey Fly Pacific, hey Sol Invictus. Some Orca love. Yes, I can give you some Orca love. I just cleaned up my Orcas from the last bundle. When I say clean up, is remove the thing in the motors. They are still pretty dirty as fuck. But yeah, some Orca love. Here you go. It is still my daily driver bundle frame. Hey Pab. All right, so let me pull the right ones. I will see if we can. Last one, I replaced two and managed to lose two of them. Let's see if I can do better this time. So we're looking for 22R. That's this one. With a few of them, they've already taken off. All right, let's go to the microscope. Tweezers. So what I'm going to do is try to drop it on the board somewhere that's recoverable and try to not have the thing ping. Oh. There we go. It managed to ping, but down on the board. That's good. Exactly in place as well. So that's perfect. Now I just need to put some flux on and solder it. I'm hopeful that I won't send it flying. These tweezers are better than the ones I used at the start of last stream, where I send the thing flying. I also need to make sure I don't burn myself, because I have my fingers quite close to the tip, as to be precise. So I want to not burn myself too. Okay, started melting on one end, melting on the other end, and we're good. Easy. Easy peasy. Now just need to do the same here. I'm getting better at this 0201 stuff. That's good. Because I have a feeling that it's not going to be the last time I do it. There we go. It hasn't pinged off to the other side of the world. It's there. So I just need to put down some flux. Grab. Wrong direction, wrong face. Let's try to flip it without sending it to forever land. There we go. Grab my hot air. Manage to grab. So I need to manage to grab this. When I grab it, I need to grab it high enough on the component that I don't. If I grab it too low, shit! I managed to ping it away. I had it grabbed incorrectly. I had it too high. If I grab it too low on the component, then I can't place it down because my tweezers are going to hit the bolt before the component. And if I grab it too high like this, it flies away. Let's see if it's ended up on the bolt somewhere, but I doubt it, so one lost. Here I was kind of trembling because I couldn't get a good hold, a good location for my fingers to sit at, and yeah. That's broken, that doesn't matter. Yeah, can I see it by any random chance on the mat? I doubt it. Could be under. Nope. Nope, it's lost. Let's grab another one. Unless it's this thing? No, it's not this thing. I'm looking at random stuff on my mat. But no, let's grab another one. That's why we have a bunch. Oh well, I was happy I managed to do the first one, but I guess can't get lucky all the time. 22R. I think I have 25 in total. Managed to waste 3 of them yet. I'll cut this a bit shorter so it's easier to work with. All right, let's try it again. There we go. This one's here. Let me put back a bit more flux on the thing, on the pad. And let's try it again. Let's see if I can grab it securely. I'll clean up my tweezers quickly. They got some bunch of flux on them from the first one. I think clean tweezers so they don't stick to the component are a good idea. Okay. Let's see if I can grab them cleanly and hold on to them. Hold on to the. There we go. I think I have it pretty secure here. Should be all right. I feel better than last time. I'm burning my finger. You can't see it off screen. I'm kind of burning my fingers. There we go. I think it's good on both sides. Let's see. Let's focus. Yep, I think we're all good. All right. All right, all right. Let's clean it up and test, see if the motor works. It was starting to work better when we replaced the two ones that were damaged, and now it should all work fine. I'm hoping. We'll see. Let's see if I can find the wire harness I was using before, or if I managed to lose it. It's a good question. The issue with doing two different live streams that are treating two different problems means between two live streams stuff changes. But I think this might still be the right, we'll see, the right connector. Let's see. It would be not at all the right connector. It's not even the right size. Okay, so I think we used a fairly normal standard connector for this ESC. That would be, yeah, so that might have been this one where it was ground, but I was using the red wire, and this on the other side has ground on the red wire. So yeah, that will do. Okay, so that's the right one. Good, good. I don't want to start wasting everybody's time repinning. Let's see if the motor spins well. We only need to solder this one to start with, and if it spins decent, we'll connect a few other ones so we can do a RPM comparison. Let me put a better tip. And let's do the thing we do 20 million times every stream. Oops. It is heated up. It's not the biggest tip. I probably should have equipped a bigger tip, but that should do it still. I'm kind of hopeful it's going to have fixed it, to be honest, given how much better it was after I switched to two other resistors. So yeah, hopefully. Let's go for the alligator clips. Let's try to not get it backwards. Okay. The last time we weren't getting, most of the time we weren't getting LEDs to light up as well. That might be a good clue. If we do get them. It means some of the, it's not guaranteed to get, oh, it's telling me USB not recognized, which isn't good. Hopefully, it's only, we good. It was just dirt in the plug or something. So we're looking at this motor, and let's turn it on. We're getting lights at least. It's not a proof. Can't remember which motor it was. I'm going to spin them all and we'll see quickly. Okay, that's spinning super clean. Let's check its motor 4. Let's check with the thermal cam, because we had something that was heating up. Hey, Bags. Welcome, welcome. We were looking into an ESC with a damaged motor. Well, it's the continuation of last week, so we did a lot of things to fix this ESC, and we might just have finished it. So we'll double check with the thermal cam, see if heat is looking good. So we're looking at the FETs, and I'm going to spin with my left finger. Well, it's all looking good. Let's see if we can ramp it up. Yeah, that's 50%. It's all looking perfectly good. Let's wire up a couple of other motors and we'll double check that the RPM is consistent. And if that's the case, which I hope it will, it means it's fixed. And I'm very happy with this because there was a ton of damage on this board and we managed to fix it, and we're not even using the right FETs. We're using like similar enough FETs, which is something I kind of knew should work, but I also never done, so it's a good thing if it does work. It means I don't need to necessarily go get the exact right FET on AliExpress, wait for a week or two, maybe get scammed by fakes like I've had before. And yeah, so that would be a great thing. And I have plenty of SpeeDB FETs because those ESCs tend to die. So that's a lot of donors. That's great. After that, hopefully that's fixed, we can look into something else, which is probably going to be a flight controller, because I have a bunch of ESCs in the box, but I am running lower on flight controllers, so hopefully we can add a couple of ones to the repairs box. I have a friend from Discord who also is sending me some bigger AIOs to look at. That's going to be an interesting session as well. It's going to be looking forward to receiving that. Obviously, if you all have stuff you're not doing anything with and want to contribute to the stream, hit me up on Discord. Obviously, it would be a donation, so it would be your charge. I'm already doing repairs for free. I can't also just pay for postage. But if you're feeling generous and want to ship me some dead electronics, hit me up on Discord and I'll send you an address to send it to. All right, so this time I'm going to show you the RPM data. In the screen share. All right, and we are looking at getting very similar values in the RPM. We're getting very similar values, 5.6, 5.7K. I think this is done, fixed. I'm so happy I didn't leave it there last time and kind of continued looking into it, because it was pretty dumb of me to not check the gate resistors of the two other FETs. We changed 4 FETs. 2 of them had dead gate resistors. It made sense that the other ones would too. So yeah, pretty dumb of me, but I didn't stay dumb, and that's good, I guess. Next time, let's try to not be done in the first place. All right, I'll desolder this quickly, put it in the box, and we can move on. Makes me happy. I love fixing stuff. I love when it's all nice and repaired and it's gonna fly again, and people are gonna enjoy their cheap stacks for their cheap builds. And yeah, that's awesome. That is why we do it. It's interesting because recently, or ever since I started doing the streams, I started watching more YouTube electronics repairs. And one of the big guys on the repair scene, which it's not anything to do with FPV, but it's a channel called Northwich Fix. He's a guy with a bit of a interesting character, quite direct, very frank and everything. I guess some people, like, it's not for everyone, but I find it very interesting. And the thing I really like is this guy who's been doing repairs for probably 15 years. When he repairs something, you can see the smile on his face. You can see the enjoyment and the satisfaction of having fixing things. And I feel like this just doesn't go away. Just keep repairing stuff. And every time it's just feels like you won against the universe trying to make you discard, throw away electronics, and you managed to save it and you won. So yeah, that's, so let me show you. I'll show you actually the status of the box, the repairs. I'll put that away. We have a couple ones claimed by a friend. So that's an 1S AIO and a flight controller. We have a 2S AIO in this. We have a flight controller here. And in the box, we still have a 2S, 3S AIO, an AxisFlying flight controller, and now four ESCs and a SpeedyB TX800 and a Ratel 2 camera. Pretty good haul. Let's see if we can add to it. Let's go. If, as always, I probably should keep telling it because there's always new people on the streams. If you want to ask any question at any time, whether it's repairs related or generally FPV stuff, feel free to ask in the chat. You can tag me at Krhom, Krhom, to have my name light up in orange, and I won't miss your question, though usually the chat isn't that busy that I wouldn't need to miss a question. And if you want to ask questions on voice, because I'm usually looking at my microscope, or I might be looking at other things, if you want to ask a question on voice, feel free to join the Discord and join the voice channel. As long as you don't make like, as long as you take up clogger the can't find words. As long as you don't talk too much and let the stream be the stream. You're very welcome to be on Discord and ask questions and participate. No problem at all. You're welcome to do it. All right, now that is said, well, let's look into what we're going to repair next. So I have a big box, which used to be Danza's box, but I'm putting a bunch of more stuff in it recently. And I think I might want to look into this that I have 2 or 3 of. I think I have at least 2 of them. Well, that's going to be an interesting repair. There's a bunch of tiny components that it's swapping, but it's an ESC and I don't need, I'm already chock full of ESCs. So I think we're going to look into those 2, which are the same. They're Argus Echo from AxisFlying, I believe. And because I have 2, I'm almost guaranteed to be able to fix at least one by using the other if I need. Obviously, if you want me to show you anything specific about how to diagnose or repair any part, let me know. But other than that, otherwise, we'll look into those. Okay. So let's start by the thing I don't do enough, is a thorough visual inspection. And let's go to the microscope. I'll put them under the microscope and we'll see if we find something that's very obviously damaged. Before I start plugging stuff in, I probably should do that more. Let's zoom out. We don't need to be that tight. Let's make sure you guys see it well. All right. I see something maybe. Let me grab tweezers. What's this? No, there's just, thought there was discoloration, but it's just surface markings. It looks very clean. It looks barely used. Maybe some conformal traces of, I think it might have been conformal coated. I might have removed the conformal coating. Maybe let's see actually if it glows under UV, which is which would be a marker of the conformal coating. If I can find my UV pen. Doesn't, yeah, that might be glowing a bit. So it might have been conformal coating. It's nothing very obvious. Right, let's see the other side. That looks, yeah, there's nothing that looks bad here that I can see. Oh, I have a new, I always have new gadgets to show you. I have a new gadget I'm going to show you for this board. That's the wind bond. Yeah, so I think there was some conformal coating. It might be, oh, yeah, you can see it kind of shine around those components. I removed it. What do we have here? Huh. What's this supposed to be? Let's see if we can see on the other board. Huh. A cap and a resistor. And there's no cap and no resistor. Okay, interesting. Are those relevant to anything we care about? That's a good question. Might not be. But there is 2 components missing. I do have spares to replace them if I can get the... I might just replace them regardless, just in case. But apart from that, nothing looks too wrong. It's around the CAM2, I don't know, it might be irrelevant or it might be relevant. So maybe it's for a UART you might not use or anything else. Right, let's have a look at the other board. This one has, so that's a 12 volt rift pad. 12 volt should still be coming through the plug, but I might try to repair the pad. Why not? Could be good training. Apart from that, yeah, looks good enough. Is that? Yeah, it's just sticky residue. Actually, I can remove this. To remove this, what I'm going to do is heat up the board a bit, and then come with some IPA. I'll heat it up, make it melt. Just flux, plenty of old flux. And I can come with my trusty sponge and clean all of that up. Much easier than trying to scrape gunk, sticky gunk away. There we go, much better. Much better here. Could do with a bit of cleaning as well. Now we're seeing what we're doing. We can see what we're doing. Right. It looks like it might be shorting to the pad next to it, so I'm gonna give it a quick wick. Quick hit with the wick. Let's try to do it that way. That wick smells so good. The sweet smell of flux. I know, I'm dying. I'm killing myself with this. That's fine. There's some weird thing. That's probably remaining bits of wire from previous soldering job. There we go. Cleaner, let's give it a bit of a run through the cleaner, and then we'll look at the other face. Let's see if we can do like a coin joint debugging, troubleshooting, fixing, do 2 boards at once. Yeah, nothing special here, nothing looks damaged or anything. So yeah. All right, so next step is to plug them in USB, through the NERC protection debugging thing. And we'll see if we get something through. So this. Grab my other way too long wire. And try the first board. So we're looking at the LEDs here. I'm gonna zoom you in. We're looking first to see if we get status LEDs and sign of life. And here we don't. So probably I'm seeing if the STM32 is heating up, but it's not. It's probably the STM32 that's dead. That's an easy swap. Let's try the other one. And that's not even that. So that might be the 3.3 board back that's dead. And it's also not heating up. Let's see if we can get some data from the thermal cam. So here, this one, which lights up, but the 3.3 doesn't, the NCU doesn't. I'm not really sure what yeah, actually in both cases, I'm not really sure what to expect. Zoom you out a bit. You can see the thermal cam. Okay, nothing's getting hot on this side. You can see the reflections from the heat sources. Okay, that's getting 25 degrees. That's not even hot. You can see my fingers glow bright. Now that would be a diode. It's a diode, so I would not expect that to be relevant. And the other one, okay, we got a cap that's hot. Actually, that might be a cap that's shorting something. So, and we get the regulator that's hot because it's trying to light up something, but it's not managing to because something's shorted. So let's start with this one and see if the cap is shorted. That looks like it's very likely. Let's go to the microscope. Also, the thing I wanted to, actually, I'm going to show you this accessory now. So at the moment, I'm using this kind of vise. And it's really nice because it has fairly thick openings here, so you can put thick boards and boards with plugs and everything. But it will sometimes try to push when you put the thing in, which has a bunch of plugs on the bottom. It's going to try to push on the plugs. And when you heat up the board on top to change something, the solder softens and it might move the plugs. It's been a bit frustrating. So I've just got this new one, which I feel like is going to be very, very nice. It's this, and I have those 4 points, and I can just put my board here on the edges and then put some pressure on it. It holds it really firm, and it only puts pressure on the corners. So yeah, I'm really liking this. So let's go to the microscope and see if we can see. So this is the thing that was getting hot, and it looks like it has taken it. I didn't notice, but let's see if it's shorted. We are going to continuity mode, the beep mode, and I'm expecting we're gonna hear a beep. We are hearing a beep. Let's remove this guy and see if he's the reason it's shorted, but it looks like it's very likely because he did take some damage. So I'm still on the same settings as before, around 450 and 60% airflow. It should be fairly quick to come out. Yep. And the good thing with having a donor is I can just pick up the donor and measure. Though I don't think I have. Yeah, it's no longer shorted. So hopefully when we swap this cap, it all comes back to life. So I need to find, let's see if we can get read a value from the other one. So I'm gonna put the other one here in my board, my holder, and see if I can read a capacitance value that's relevant. In circuit, it's never guaranteed that you can read it, but we're gonna give it a go. And we're waiting, it takes forever to measure capacitance. Needs to go through the auto range, the whole range of values before it can decide to give me something, if it does. That meter is not very good at measuring. Oh, there we go, we get maybe. Okay, what I'm gonna do is first log this better. I'm gonna get my old multimeter, which is way better at reading capacitance out. The new one is great because it lets me show you the values, but here you're gonna have to watch the values on the small cam or just wait for me to give them to you. Okay, so I can see here it's trying to measure and then it's going back. That's because in circuit it's almost impossible. I'm pretty sure I can grab pretty much any capacitor that's about the same size, and it's going to be close enough in value that it won't matter. So that's what I'm going to do. I'm going to grab an ESC. I think ESCs probably have a bunch of them on there, and I'll see if I can get the donors. This brush ESC, is it the same size? I think those are way bigger. Okay, not the same size. Maybe this guy. No, still big ones. Actually, is it? If it's one of the sizes I have in my store, which the biggest size I have is 0805. Let me grab my 0805 capacitors and we have a look at whether it's similar in size. I still don't know my size, my capacitor size as well. So if it's the right size here, I think it might be. Yeah, it's the right size. So I'll grab the largest capacity I have on those. 22 microfarads. What I'm going to do, I'll remove this one. I'm going to try to do it well. So I'm going to remove the one from the good board, measure it out of the circuit, and then put it back on. It's going to be the easiest way to do it. And let me grab my tweezers if I can find where I put my tweezers. Okay. Let's kill a nice working board, shall we? I'm going to try to not have it ping to the other side of the moon. Right, so I have it here. Let me put it under the scope. I will try to measure it. Let's see if we can measure it without sending it to 24 microfarads. I have 22, that's going to do. Let me put this one back. And I now have a bunch of spares anyway, so I just need to manage this. But if I were to lose it now, it doesn't matter as much because I know I can replace it. Let me focus you guys. Let's do a bit of tinning with leaded to make it easier on myself. That's a lot of leaded, but it will do. It will do. And then we'll do the other board. We could put this one on the other board too, but so we can test faster, but I want to keep our other board, this one with its own cap. Okay, might come and clean it up a bit with a bunch of flux and my soldering iron. There is a lot here, so maybe I can remove a bit. Yeah. There we go. Better. Okay, so let's grab let's prep the other board. So flux. Oh, what's that stupid hair at the end of my flux? Okay, let's see if we can clean it up. There might be an old pad. Actually, no, there isn't. I'll put on some leaded. Let's see if I can pick up a tiny bit of the southern ball. If I clean up my iron, I can pick up some of this because it's gonna come onto my iron tip. Okay, now we grab a cap, we clean up, put some flux, grab a cap. We need to clean up with some more sponges. Okay, flux. And grab a donor. So that's this guy. .22 microfarad is here. Let's see if we can get one without sending it to the moon. Doesn't look like an easy job. Let's see if I can actually do it from the other side so I don't damage the 22 microfarad sticker. So I know what this is. Let me. So it comes. They come bundled in a. How do you call those clips? Actually, I don't know how you call those in English. Those kind of baby. Oh, it's all coming apart. No, it's not. So let me keep the 22. That's the 10. Yeah. Okay. Let's see if we can do this. When the biggest challenge of your repair is opening a reel of components without spilling the components everywhere. I don't know if it's a good problem to have or a bad problem to have. It is a problem I'm having. Let me try to tidy it up immediately so I don't run the risk of losing it. There we go. Okay. Let's solder this motherfucker. Okay, hot air. It should be as easy as that. There we go, perfect, in a few seconds. Okay, let's see if, well, let's check that we don't have a short. There's no reason we would, because we checked after lifting the cap. We don't have a short. Let's see if this comes back to life, and it was just that. And the board isn't even warm. Oh, safety pin it's called. Thank you, Mini Madness. Yeah. Here we call them... no, I can't tell you because I don't know the translation for one of the words. But yeah, that's good to know. And a true surgeon, I wish surgeons could come in, repair you in about 2 seconds, but unfortunately that's not how it works. But I am getting better at getting the components on and off. This was a pretty big one by usual standards. So let's see what this does now. So once again, we're looking at the LEDs here. See if I can light up. Okay, lights up, blinks. Let's go to the PC. I can see Betaflight STM electronics. Let's go to see if the thing's working. Yeah, yeah, that was probably the only issue, most likely. We'll test that they spin motors later. We'll test both at once. I can repair them both. Let's see if I can repair the 10-volt pad, or if it doesn't make sense to do so. And that will, because I want to have fun repairing the pad, so let's try that. But yeah, that's good. That's good. Always amazes me that basically, like we're talking this cap here that we changed, which is here, that's like maybe 0.1 cent. And because of this, the whole board would have gone to the trash. It's just insanely silly to me. That's how stuff works nowadays. But obviously it has to, because nobody can afford the hardware, the time, and the expertise, and everything else to repair those boards. And like that's a 50 to 60 euro stack. So that board is probably like 20 euro. Why would you go and pay someone to repair it? Who would accept to repair it for less than the price of the board? So it is throwaway. It's just sad. So it makes me happy that I get to have fun in my repair hobby, and at the same time give my friends opportunities to fly for cheaper. And if one day I open a Patreon, I'll let Patreons opportunities to get those repaired boards in some way. That would be a great way to kind of give back. But that's neither here nor there. That's probably one day if I get the time. Let's see if we can fix this pad. It's luxury. Fixing that pad is just luxury because you don't need that pad. it's not like you can fly without that pad. Even on HDVTX, we can just direct solder to the LiPo, and the plug is still there, so you can solder to the plug. I can see it's only coming from the vias. So let's grind. Let's pull out our favorite toy and grind stuff. Let's see if we can reveal some more copper. So there's a tiny bit of copper here left, and I'm going to keep it. And then I'll reveal the vias, and I'll build a pad with no, it's going there. Let's see if we can keep it. Let's not touch it too much. So you have vias here and this bit of copper, and we'll have to do with that. So I'm going to clean this up, and we'll see how we can build a new pad. I have ordered thin sheets of copper that would let me rebuild the pad better here, but I haven't received them yet, so I'm gonna have to do with like probably wick. Have I grinded enough here? Might not have. Let me give you that's a bit more. This via a bit more of a grinding here. Don't want to go too deep and reach another layer of copper, which is likely to be ground. So I can't really go super deep, but I want to be able to solder to it. So let's see if I can get some solder to stick on this via. Let's put some flux on them. If I can get some solder to stick, then I can just create a pad and solder it to them. Might try with some solder paste actually. Might be a good way to go and reach inside, because I'm barely getting any stickage here. Okay, let's see if I can do it with a thinner tip and some. So I'll get my thin tip again, and I'll get some solder paste. Where did I put the solder paste? Here. I'll clean it up first. So we know what we're doing. Well, I guess I eventually finished tearing off the rest of the pad. Let's see if I can get some of that via revealed again. Okay. It's like, yeah, I'm not sure I'm going to be able to save this spot, but we'll see. Let's put down some solder paste here. See if we can get it to. That's some old ass solder paste. It's dry. It will do. It will do, pig. It will do. Put it there. Obviously you can melt it to the via. Oh, it's not heating up. There we go. Okay, it works for this one. I did get some tinning. Okay. There is some tinning on both. So let's see if we can get a tiny bit. I have those pad stuff. Let's see if the replacement pads I have can get us somewhere or not. But I think they're just too small pads. The pads are too small. So let's see what it looks like. It's this thing. And maybe I can use a bit of the copper, actually, copper sheet. Let's try that. Yeah, I might be able to use a bit of the copper sheet. Let's go for a bit of a cut. Let's bring this bit of copper. I think it has a protective layer, but let's go to the microscope and see what I did. That could do. Yeah, I think it does have a bit of protective copper on top. I need to cut the bottom. I'll do that quickly. I'll just do it quickly. I can give you the overhead camera, you won't see much. Gonna hold it, cut the bottom. There we go. Let's go back to the microscope and let's see if I can try to understand what kind of protection layer it has. I think this is plastic on the bottom. See if we can remove that with a couple of tweezers. Can we peel this? Looks maybe the other way around. We can peel the copper off. It looks like copper foil. Yep, looks like copper foil. Let's see if you can peel it. Yep. Try not to damage it. I'll do it the other way. I'll use the other tweezers to see if I can peel it off. Try to hold all this for now. There we go. Okay, so now what I want to do is be able to tin this side, and then I can flip it and try to, or tin the other side. Up. Oh, it has some stickage. It has a glue. Interesting. Hopefully I can burn that glue away and put some amount of tin to stick. Let's see if I can use my iron to burn away the glue. Yes, I can. Or burn or move away. Okay, good. Now we should be able to adhere some tin. Oh, it smells like shit. Okay, let's put some flux on it, and might need to hold it down. Oh, it's going to come with the flux. And see if we can get some tin on the tip of my iron, and then hold it with the tweezers. And tin it. Yeah, all good. The reason I want to tin it is to increase the chances it's gonna stick to the, let's put a bit more, stick to the vias. And then we'll secure it with some solder mask. Okay, good. Now let me flip it and see if we can get it to bond to the VS. I'll quickly clean the pad and put some fresh flux. In this flux on the two VS. Flip this upside down with the right tweezers. Oh, okay. Now this is a good spot, and this is the right size. So now we'll heat it up. We'll heat it up and see if it sticks. And if it does, we'll secure it to yeah, looks like it sticks. Okay, so what we'll do is clean it up, see if we get 12 volts. And if we do, we'll tie it down with some solder mask. And that will be a repaired pad. Clean it up. Yeah, so it's not coming off, so it means it's connected to the via very likely. Good, good. Guillaume, you're asking, why don't I dig the whole pad? The under it is very likely to be a ground plane, and we don't want to connect to ground, connect to 12 volt. When you saw me do the Voltara ESC, I knew that under it there was the same pad. It wasn't a ground plane. That's because I know the schematics. That's because the creator of the ESC told me the schematics. Oh, I think my thing is damaging the side. Oh, maybe it was already damaged actually. The top one isn't getting damaged. We might want to reposition it though. Lower it a bit, so I don't put that much pressure on it. Yep. But yeah, so when I know for sure what kind of thing is under it, I can adjust. But here I don't know for sure, and it's very unlikely to be 12 volts under it. It's very likely to be ground. But usually the stack up of those boards is like signal, ground, maybe VBAT or like power ground. But usually every second layer is ground. It's for like electromagnetic emissions reasons, I believe. I'm not really sure. Okay, so wanted to test. So first of all, I'll test that I'm not shorting to ground. So I'll test that pad and ground. No beeps. Yeah, no beeps. Do I have another 12 volts? I have one in the plug, but is there another one on the board? So I can check continuity. Yeah, here. But it's not guaranteed to. Oh, there we go. I know I'm continuous because that's the LED for the 12 volts. So yeah, if I'm continuous, my pad is good. I'll still test it just for So that way I can test that the 12 volt does work. I need to power. Do we have a bat? Do we have a bat that I can solder to? Bat, yeah, ground bat on top. I'll just quickly solder a pigtail on ground and bat up there. We have a XT30 pigtail. I'll do that quickly. Can I actually use this to heat up the? That one gonna work fine, I think. Those tiny tips, they don't heat up much. Yeah. So I can do bat barely, so I'll change the tip. Oh. Yep. And because I can't be bothered to do a ribbon cable for this, so I'm just soldering to. Let's see if I can avoid stuff from being shorted. Yep. There we go. Now I'm gonna put 16 volts through to the thing, and I'm gonna put my overcurrent protection on so I don't burn it up, just in case. That way you can check we have all the voltages. So I'm gonna go to volt mode and we'll check the BECs because it's something we need to check as well. Let's go. Okay, we're getting the right number of peaks. We're getting blinking. So I'm guessing we're gonna be good. So let's go ground here. And here we're getting 12 volts. Good. We're getting 5 volts here, I'm guessing. 5 volts. And 3.3. Do we have a pad for 3.3? But we know it's working. The thing is blinking. All right. Now we just need to tidy up the pad and we'll be done with this one. Let me remove the. Actually, let me remove first the lead. Right. So now we just want to add a bit of protection to. I'm gonna grind a tiny bit around it so that the solder mask adheres well to it. Let's zoom in. Let's go in. So I don't want to reveal copper necessarily. I'll do another cleanup as well. Don't want to necessarily really reveal copper, but I want to give something for the UV mask to adhere to. So I want to scratch stuff a bit around. Don't feel like I'm scratching a lot, but I am scratching something, some amount of things. Okay, let's bring the solder mask and my tiny oiler thingy. Hey, Moose. By putting the copper layer on the pad will conductive enough to pass a large current. So I'm restoring it to exactly what it was from what we've seen. There was only 2 vias bringing 12 volt into that copper pad. So at the moment, it's exactly the same as it was before. But yeah, that's so it won't be worse in any way. You can't really carry much current on those anyway, but only a few, like a couple amps at tops. But yeah, so let me see. I think that should still be uncured. So I'll just bring a bit here. Up. So I saw your question. I think it's Joe. I'll come back to it in a second after I've done this. There's a bunch, if I can sneak some under the pad. It's going to hold it nicely. Let's go all the way around. I don't want to go over the pad and block on the ability to solder to it, but I don't want people who go and solder to it to have the pad come off with their wire. I want it to stay there, connected well. There we go. I think we're decently okay. And we need to cure it. And as I've shown before, this new solder mask I've got is amazing and cures in a few seconds, especially when you put some hot air on it. So I'm going to do exactly this. I'm going to pull out my UV lamp and plug it in. And then I'll put my hot air on 250. And I'll have hot air on one end and UV on the other. It's already cured. I can see it's already be cured, but I'll give it another few seconds. That thing is amazing compared to what I had before. There we go. And I'll show you that it is indeed hard. You can see nice and hard and nice and sticky. There you go. And I'll tin the pad to give it the same appearance as its neighbors. There we go. 12-volt pad repaired. Okay, and then we're fully good on this board. That's another one for today. We're on fire today. And so we have a question from DKZ. Have you ever tried fixing a built-in analog VTX on an AIO? Yes, I have. The only time I've had to do it, I just had to reflow it and it worked. It wasn't re-damage. It's something that happens on the wood boards, especially the air boards. You can get like bad behaviors on the analog. It just start breaking up, or you get bad OSD, and you just reflow the parts because they're on this board specifically. It seemed that the solder is not very good or not very well applied, and it kind of breaks. So you just heat it up with a bunch of flux till it melts and slightly moves, and then you're good. Mini Madness, you're asking. Don't know if you answered this, but why not get 12 volt from the back pin instead? Because I had the wires, so might as well keep it clean. If I had to, I mean, I didn't even have to repair the 12 volt because there's still the plug. You can just use the plug and it has 12 volt in it. But I can get 12 volt from many sources, and I could repair the pad that way. But if I can repair it from the vias under it, then I might as well. It's cleaner. Hey Baloo. Hey Joseph. Hey, you have the same grinder. Well, would it be a shame if we didn't see it on the stream, Joseph? Give us a stream, Joseph. So Joseph is a friend from Bardwell's Discord and a really great guy who teaches a bunch of things to a bunch of people, and he's started gearing up to do some repairs, and I've yet to see some repairs. So come on, Joseph. Yeah, Minimalist. It was mostly to have fun getting used to doing pad repairs as well, and having fun cutting a bit of copper as well. was just for fun and games. What's the brand of UV glue I can show you? It's the ones you want, and I didn't invent this. It's I got the information from Nanofix test. It's the Relife, and you want the 3 seconds fast curing oil. I don't know what they're calling oil. It's not an oil. It's Chinese translations. But yeah, they have them in a bunch of colors. The one I prefer is the transparent one, which as you saw is white, but it's kind of transparent. And yeah, that's amazing. And with a tiny bit of heat, it cures even better. So yeah, get this shit. And at some point, I promise, I will take the time to write down a bunch of things in the description of the videos with all the hardware, but I've not done it because I keep prioritizing other things. But yeah, I'd say 90% of my gear comes from his recommendations. So, though I disagree with him on some of the tweezer choices, I'm starting to build my own opinion on things. All right, so that is fixed. Now we'll need to fix the other one. It's still in there. I think that's the one that just, oh, I can't remember. Is it the one that didn't light up at all? Or the one that had, okay. So that one does light up, but it has the 3.3 that lights up, but the MCU doesn't. So it's very likely a dead MCU. I'm checking on the PC. Yeah, so it's a dead MCU. Let's swap the MCU and we should be good to go, I'm pretty sure. Guillaume is asking, what's the best way to remove a JTS connector from the flight controller? I'm guessing you mean, yeah, those JST ones. JST, funny if you don't know, stands for Japanese solderless terminals, because they are crimped and not solderless. If you want to remove it, I mean, I would do hot air, especially if you don't want to keep it. You can just blast some hot air and it's going to come off. It might melt. And then you put some leaded on top of it, and you can put the new one with hot air, and it shouldn't melt because you won't stay on the heat that long because it's leaded. You can also clean everything with the wick and then put it back on with a soldering iron. That's going to work well, though I can show you. The issue with the soldering iron is the corners. So you can see that it's soldered from underneath here. So if you want to solder that bit here with a soldering iron, you can do it, but you're going to melt the plastic here. So if you can just hold this and then come with your iron and heat it up from the side, and it's going to melt a bit of the plastic, but that's fine. But with hot air otherwise, that would be my suggestion. All right, we said we are removing the MCU.
Curiosity, I have a little question, my man.
Go ahead.
What's the little device you used on your left to power up your FCs?
So are you talking about this thing?
Yeah, exactly what it is.
It's a multimeter / analyzer for USB devices. What I'm using it for is, you can see it has voltage and amps, and it kind of acts as a fuse and protects my PC. So if something's shorted on a component, so it will damage this instead of damaging my PC, or most likely won't damage this because that's designed to react to variable loads. And it will tell me the amp draw and everything. So it's kind of a buffer, a safety buffer.
It's new?
I had it for a while. I've used it on a stream a few times before. When I want to plug an unknown FCs on my computer, I just use this as a buffer. Once I know they work, I don't have to. All right, let's get back into focus. Okay, let's show the microscope, because focus without the right thing doesn't help. So, I mean, there is a world where those are part of the thing that powers the MCU. So let's see if we can replace those first and see if it boots up before we start taking the thing apart. I'll see on the repaired one if I can measure what They are like, but with any luck, we can measure it, and we don't have to. The resistor, we should be able to measure. The capacitor, toss-up. It's a toss-up whether we'll be able to. So let's go for the resistor. And now we wait. Oh, it's oh, if it's indeed a, so I'm reading not from 0.40 ohms, and if I touch my probes, I should read about the same. Yeah, or a bit less. So it means it's most likely a fuse or a very low ohm. Yeah, so it's most likely a fuse basically. So a 0 ohm resistor. So that might be super relevant at powering the MCU actually, because usually fuses are designed to carry the current to somewhere, so it's not just protection for something. And I'll check the capacitance of the other guy, if it will read. I'm guessing it's going to be, can use any random, a few nanofarads, like 100 nanofarads probably would be fine. Can't read it. Oh yeah, I can 5 millifarads. No, that's fake news. Yeah, that thing won't read it. I think it's just not in circuit, you can't read it. This one I don't want to remove and measure because it's a tiny boy. It's probably, let's see if we can check if it's tied to, so I can see the trace. So this is bringing some voltage to, let's see if we can quickly find out where it's tied to. So we can see, try to understand where it's, so I'm guessing it might be from the 3.3 volts, actually. It is. No, it was just a cap, so short. Is it ground? No. Oh, it is 3.3. So that's the fuse that brings 3.3 into the MCU, and that cap will want probably something. Grimka, actually, can you remember the kind of caps we put next to big stuff? I think it's like 100 nano is probably fine, if you remember. Well, I think I'll probably put 100 nano or something similar here, and 0 a fuse. So for the fuse, I can just bridge the pads. We'll do the same, but might as well put a fuse if I have one. And yeah. Yeah, Fire Mike says you can heat from the other side of the board to remove a connector. If you don't want to burn, yeah, that's a good way to do it, to not burn the plastic. But on some boards, it can, and you run the risk of damaging what's on the other side if there's something that can melt on the other side. So it's give and take. I don't have a definitive notion of when you want to do one or the other. Okay, let's grab some components. So are those 0201? Might be, actually. We're doing a lot of 0201 today. 0201 resistors, and we have some 0 ohm, and then we want the 0201 caps, and so we have those for the resistors. I need to find like 0201 caps. 0201 caps from 1.1 pico to 2.2 micro. So I'll do them in order. Let's go and prep the prep the pads. Actually, can I do it with this? Yeah, I might be able to do it with this. It's going to be easier with a big tip to clean them up. Because there might be, yeah, there are pads. I think old pads. I'm not seeing. Let's see if we can see better with. Yeah, there's some damaged pads from the old components. Let's clean it up. And wick. My wick. Where's my wick? Here is my wick. There we go. Come back with some fresh solder and flux. There's definitely ground in one of those sides. I can feel it in my iron. It takes a while to, like a half a second to melt. And you can really feel it as you drag your iron across it. Okay, let's try to not mess it up. I'm pretty sure the resistor is at the bottom. And the resistor is indeed at the bottom. So let's do the cap first. So I'll go for 100 nano, should be good enough. 100 nano here. Oh, is it the size, one size up? Oh, it is it is easy mode. It's not 0201, it's 0402. Oh, that's going to be trivial. I'll need to pack up everything, so I pulled the wrong ones, of course, then packing up all the other ones, making sure I don't lose, oh, like there's so many of them, if I start mixing them up, it's going to be a nightmare. And let's go for let's find some 0402. 0402 resistors. And there's 2 box of capacitors. And I want 1 NF. This one. And I got those not thinking I wouldn't use them very often, and I end up using them very often. So that's good. I'm happy I got them. That bag with a bunch of values is like 1.5 to 2 euros. So it's super cheap to get all sizes. Let's go for where's 100 NF? Yeah, that does look like the right side this time around. Oof, that almost pinged to nowhere. There we go. Flux. Much flux. Much flux. Okay. I'll try to get a good position for my hand. So I try to lay my wrist in a very convenient place so I can get a lot of precision. So I'm on 450 and 450 degrees, 50% airflow. I probably should have changed it to a bit more airflow, but there we go. Melted on one side, melted on the other. I'm gonna reflow it. Oh, did this move? I think this might have moved. The one from before. Let's heat it up again and put, there we go. Go back to your spot. There we go. Kept moving. So I'll reflow this guy because he's not laying flat. There we go. All good. Now let's do the resistor. We want a 0 ohm. So here the fuse not only blew up, but just disappeared, ceased to exist. It might have been, probably physical damage that ripped it out, because otherwise we'd see traces of dead components. Oh, sorry, I didn't switch the scene. So you have to trust me, this guy is now on the board, and you'll see the same exact thing for the resistor. I'm so sorry, I'm getting mostly better at switching the scenes, but this time I forgot. You did have a sneak peek, I think, in the bottom. So yeah, it's not all lost, but yeah, not great. Sorry, guys. Right, let's clean up a bit. So let's not lose our resistor. Clean up a bit, put some more fresh flux. Okay, I have a good position for my hand. Let's bring in hot air. Okay, so I have it tacked on one end, and the other end hasn't melted because it's ground. So I'm gonna come in, put some more flux, and see if we can melt it in place. That side melted, the other side melted. All good. Okay. That is now repaired. Let's clean it up and see if we get some signs of life. Of course, I always forget to say it when there's a bunch of people interacting, but as always, if you don't mind going out of full screen for a second, if you're in full screen, and clicking the like button, that would be super nice for the stream. Keep the algorithm interested, and it's super helpful for me. So if you don't mind, press the like button, and I will be very thankful to you. Oh, it's hot. So now we have a hot board. Fire Mike is asking, is it my own board or am I fixing for someone? I'll tell you the way my stuff works, because I don't really remember to tell it every time. So how it works is that my friends, people around me who are who I fly with, or people in the community around me, When they had dead stuff that they wouldn't be able to get fixed anywhere, don't want to do anything with, you know, FPV pilots, we keep all our dead stuff. That's the thing we do. If it's not completely burned to a crisp, we keep it in a drawer somewhere. So I told people, if you're not going to do anything with it, give it to me and give it freely as a gift and don't expect anything. So I don't have any obligations to repair it or to look at it or anything, but what I will do is when I want, when I feel like it, when initially it was like every once in a while when I felt like repairing or learning to repair because I learned by doing it. And now it's more frequent because of the streams. I will spend some time repairing stuff. And when it's repaired, it goes into a box. And I have this box full of components that I've repaired from anyone. I don't really write down who it came from or whatever. When people who have given me stuff at least once meet me in real life at a spot for fly and everything, or I don't know if we go and eat out, they can pick anything they want from the box for €5 a piece. Obviously, I don't let people just grab everything and run, because the point is to make stuff available for people who are making new builds or are repairing their builds or want a spare, not for people who want to hold and resell and whatever. So it's kind of a honor system too. But yeah, people can get and pick from my box. And I have a few people who have donated gear to the stream without expecting anything in return. I can't really pay for shipping or anything. I already don't expense, like I don't ask for anything for the repairs, just €5 per component, so I can keep buying STM chips and stuff like that, and supplies and cleaning supplies, all of that. But so I can't really pay for people to ship stuff to me, but some people have donated gear, and it's really, really nice of them. And if they meet me in real life, they can get stuff from the box as everyone, the same as everyone else. That's how it works. I don't do repairs. I'm not a repair service. I don't think, I'm probably starting to have the skills to repair. I could possibly start doing it, even though I'm like still learning a ton, but I'm getting better at it, and I have had more success recently, but I just don't have time. I already don't have time to work on my own projects. So, but yeah, that's how it works. That's how we make it work in the community. And my friends are more and more flying on repair and stuff, and that makes me happy. All right, so we have this board. Let's see if we get sign of life. I'm expecting that if it died from burning up, the MCU will be dead. Oh, blinking lights. We got life. Okay, let's go to the screen share. And we got motion. All right. Well, looks like it was just the fuse and the cap. That is pretty awesome. Let's go and check the back as well. So I'll power it up the same way I did the other one, solder to VBAT and ground, and we'll check all the voltages. Guillaume is asking, do I have any original and funky drone project in the works, like the Krhom with the extra long arms? Yes, I do. I have the one that's not going to be the same kind of funky, but it's going to be heavily detailed. It's a video I'm preparing when I'm going to show the whole process from A to Z. So that's the next video I'm working on, and that's one of the reasons I'm stopping. I'm not doing the French stream on Thursdays anymore after this week, because I want to have time to work on this. It's going to be a pretty big project. It's my first sponsored project as well. I've gotten sent some electronics to put in the drone by a very nice rep from my first sponsorship deal. Well, it's not really a deal, as you know, it's more of an honor system. They send me stuff, I rep the stuff, but it's nice. It's nice. And yeah, so, and in terms of the Krhom Mini meme builds, I have a bunch of ideas I want to do. And the next one I want to do it, to document it, and kind of present the whole idea of why I do meme builds and funny builds and weird stuff, because it's kind of, I mean, it can really seem like a waste of money of making stuff that's mostly for the ball, but that still flies and everywhere. And well, people can try them, but I don't fly them regularly. But there is a real reason I do it, and I enjoy doing it, so I want to talk about that as well. But that's gonna be not immediately. I have a bunch of more other projects first. But yeah, all right, so let's check this in the microscope, solder stuff, and check the rails. Where's our bat and ground on the bottom? Okay, let's go and solder to them. Where did I put my lead? Here. Okay, but let's try to not short anything. It's not the right tweezers for the job, but will do. Yeah, I don't think we're shorting anything. Right, let's look at the LEDs on the right, see if they'll still light up correctly. And let's see if we get, okay. So it means we have at least 5 and 3.3 working. Now we'll want to check that 12 does work too. We'll go to volts, DC volts, and 12 volt is here, ground is here. Do we get 12? Takes forever. Do we get 12? All right, all good. And one more repaired FC. That's good. Man, that stream was very, very effective. I mean, to be fair, the first one, we mostly spent the full 3 hours, no, about 2 of the 3 hours last week working on it, but it was just the end, the conclusion. But yeah, let's commit those two to the box. Where's the other one? The other one's here. I'm really liking this new holder ball, by the way. Yeah, it's really nice. It's the Mijing T33 Pro. It's not super cheap. I think it's about 30 euros. It's not super expensive either. You still want an 04 hex KU Mini? Well, the thing is, I can't really release the file because it's a bit of a bootleg of an existing frame. It uses the kind of, I copied the thing, so. But if you do come to a session I'm in, I'll happily bring it for you to fly and try it. I'd love to, have it go, test it. That's the thing. That's one of the reasons I do those crazy builds. It's so people can fly them and try them and have fun and discover how different it is without having to commit the expenses to build one. Oh, there you go. That's the spirit. Well, if you have your DXF, you don't need me. Good, you're gonna make your own. It's a bit of a pain because of how thick it is, but yeah, if you do come near the south of France, near Toulouse, you can join us for a session, and you can try all the meme builds, and you can fly the 10-inch in a bando, and you can try all the KU Minis, the different variants. Okay, let me grab the box and we can add those two, so we can officially validate a good evening well done. And the box is starting to fill up. Gonna have to ask the friends to break some stuff because it's getting quite full. All right, and we are bang on, straight, right on time. So that was amazing. That was pretty good. Had fun. Last Thursday and today's stream were particularly good. So We did some trace repairs, we did some swapping of tiny resistors, we did some investigating and fixing. Very happy with this. It was successful, and I love when it's nice and successful. So yeah, really happy with this stream. Well, with the luck we got repairing the stream in itself is just the same old bearded guys saying things, but as far as repairs go, that was very satisfying. Oh, you Minimaness, you headed down to Bordeaux in September. Bordeaux is only 2 hours away, and we could always do a session in Bordeaux. There are a few banders over there as well. We know the guys over there. That would be a good opportunity if you want to do that. If you want to make sure you get in touch, in my server, there's a channel called Session To-Dos, which has a link to our mostly French, but most people kind of speak English, Toulouse team server. And you can join that, and we can all like keep in touch there when you come in and you want to fly together. But yeah, absolutely do. That would be awesome. Guillaume is saying, I'm getting my IPEX 5 frame soon, but from what you saw in my tutorial, the cam plates need to be installed upside down. No, they don't. The cam plates go in the regular way. They only go one way, so you can't really do it any other way. So yeah, it just works. You don't need to cut anything, it just works. It's a bit fiddly to assemble and line up everything the first go. After you fly it and you remove the top plate, it kind of settled into place and it's easy to close again. But the first time it's a bit fiddly, but it will work. You'll figure it out. Most people do. All right, I think we are done for today. Thank you very much, everyone, for coming. And reminder that next week we're starting 1 hour earlier, and it's going to be 3 hours, so you get more background content to keep you busy while you work on your own quads. And thank you very much, everyone. Remember to click the like button and do all the things, and share with your friends who might want to learn about repairs as well. The more we are, the more we can fix your stuff, and you can fly for cheap, and that's good. Like Joseph is going to do, and I don't know if you're still there, Joseph, but I'm waiting for your stream. All right, thank you very much, everyone. Have a good one, and see you later. Bye.